Okay, in this video, I'm going to be showing you how to make an elevator, a very basic lift, and some physics involved in Second Life and LSL. I created this little environment here in the sandbox with the two floors that are 15 meters apart with the elevator right in the middle that will go right between the two, as you'll see. I did a few different versions of this elevator, so we're going to run through all of them to show you the differences and how the physics actually function within Second Life. Okay, so we're going to start off with the basic elevator script, and a lot of these variables and functions are going to exist within all of the scripts we're going to look at. This is a very basic elevator script, and we're starting off with an integer at the top, which is the current floor, which is just either floor 1 or floor 2. Below that are the two vectors, which are the two positions where floor 1 and floor 2 exists. Next, we have another vector, which is the move to targ vector. And this is basically going to be the vector we're moving towards, which is either floor 1 or floor 2. And we also have the start rotation, which is the starting rotation of the elevator itself, which in this case is going to be a 0 rotation. It's just a platform, but it could be anything. Then we're getting into the state entry event, and the first thing we're doing is this set status function. And this one is basically going to set the physics of the elevator itself. So we're using a bar broken list or pipe broken list essentially in here, and we're setting all of the values to false. And these are the physics, which basically if I status physics is set to false, then that means that the elevator itself will not react to in-world physics. It can't be pushed, moved. It won't basically move. This is basically the starting position saying it's basically going to be static, just like any object you would start off with in Second Life. Then we're setting the rotation on all of the axes, the X, Y, and Z axis to false, meaning that once this is active and we do set the status to true later on, the physics to true later on, this item, the elevator itself, will not rotate. It's only going to go up and down, but it will not rotate. I'm using a set buoyancy function next, and this is a hit or miss. You can or cannot use this. You'll see in later scripts I don't use it. It may have some function. Essentially, this is helping the elevator float more than it actually would normally. If you set this buoyancy to 0, there's no activity. If you set it to 1, it'll tend to sink more. I like to set it to 1 because when the elevator drops, in some cases it has more of a floating function. It seems to float a little better, but it's a little hit or miss, and it's up to you whether or not you even want to use the function. But if you do, I've set it to 1 here, which is basically maximum float. Now you'll see that because of the nature of the way I use the script, it's not just going to float away like a balloon might, but it will actually, when it rises up and when it lowers itself down, it will have the effect of being a little softer, it seems. So the next item I'm setting is the torque, which is basically saying that in terms of how I'm going to set the resistance of this item, I'm going to make sure that the resistance on the X and Y axes are full 100, meaning that the physics of this is going to push completely against the X and Y axes so that this elevator will not drift to the right or drift to the left. The Z axis is at 0, meaning basically it's only going to go up and down with the set torque status, and I've set this torque to 1, but maximum 100 on the X and Y, meaning that this item is not going to move right or left. It's only going to move up and down, which is what we want the elevator to do. The next thing I'm doing is setting the position. So wherever the script resets at, and that first position is going to be the position of floor 1, and floor 2 I'm setting basically 15 feet higher in this case. And I'm multiplying that by the rotation, which again, 0 rotation in this case. So basically we're just going up 15 feet from floor 1, or rather 15 meters, I should say, from floor 1 to get to floor 2. And the starting rotation being whatever rotation we're at, which again is 0 rotation. And our current floor variable we're setting to 1. We are at floor 1. And then as we scroll down a little bit on this script, you'll see we get to a touch event, and the touch event is basically what's going to trigger the elevator in motion. So if we're currently at floor 1, then we're going to be moving to set the move target to floor 2. If we're at floor 2, we're going to set the move target to floor 1. And here's where we're going to change the physics, and we're going to set that target. So we're first going to do the move target. So we're going to set the move to target, which will either be floor 1 or floor 2, and we're going to set the speed to 2.5. This means that it would basically take 2.5 seconds for this elevator to go from floor to floor at that speed. And we're going to set the status to true in this case. And then we're setting the timer event with a real low tick. And so every 1/10 of a second, the timer event down here is going to trigger. And what the timer event is going to do is basically keep checking the current location of the elevator itself against the move to target, which is the target we're trying to reach, and make sure we're within 1/4 of a meter. And so we're using the vecdist function over here, as well as the get position, which is the position the elevator is in at that particular 1/10 of a second, against the move to target position. And if the distance between the two is less than 1/4 of a meter, we're going to trigger everything within this conditional here. So once we do, we'll basically do a stop move to target, which means we're going to stop the movement of the elevator. We're going to set the status of it from true to false now, and we're going to set the position to the actual move to target. So we're going to move the elevator to the exact location it needs to be. So it will be within 1/4 of a meter, and we're just basically going to shift it right to that position. And we're going to change the current floor number. If the move to target was floor 1, we're now at floor 1. If the move to target was floor 2, we're at floor 2. And now the elevator again will be stopped, and it's ready for the next touch event, which would move it to the next floor. All right, and so let's take a look at how this basic elevator script functions. And what you'll notice about this when it's in motion is that it kind of takes off very sharp in the beginning, and then it gets a little slower towards the end. And so it functions a little bit more like something shot out of a slingshot. It's not a very smooth moving elevator in effect. It does do the effect of moving from point A to point B, and it will take about 2.5 seconds overall because that's the speed we're moving at. And so this is very basic, and this works decent, but we're going to look into the next script we're going to show you, which actually functions a little better, and explain how to use that. We're calling this the medium elevator script. And let's open up and take a look at this one next. So we stop that first one from running, and let's take a look at this one. The top part of the script is almost exactly the same. We've added one additional variable, which is a float for speed, because the speed will change in this particular script based on the distance we are from the endpoint we're trying to reach. So everything else in the state entry event is exactly the same as well, except for the speed variable, which we are setting, although the move to target is null in this case, so the speed variable is actually not relative at this particular point in the script. And then just like the other script, the touch event is going to trigger the movement of the elevator. So depending on which floor we're on, if we're on floor 1, we're moving to floor 2. If we're on floor 2, we're moving to floor 1. So that sets the move target, and the speed is now going to be set again, which is going to be the distance between where we are at the moment and the move to target, which will be 15 meters when the elevator begins. And so that's what we're setting our speed as, which would be 15 at the beginning. We're going to set the status to true and set the timer event, just like we've done in the last script. In this variation of the script, each timer event, we're going to change the speed slightly, which is going to change the target. So we are initially looking to see how if we're close enough to the target at this point to where we're ultimately going to stop. Once we get within 0.25 meters of the end position, we'll do the same thing, stop moving, set everything to false, and change the floor. Otherwise, we will adjust the speed based on the current distance we are from the move to target, And then we'll again set a new move to target based on that speed. And what you'll see when this script operates is that the movement of the elevator is much smoother from start to finish because the speed pretty much stays the same by adjusting it every 0.1 of a second. So here you can see now the elevator moves much smoother from start to finish from the top, and also moves smoothly from the top back down to the bottom. And let's stop this one now and take a look at the third script, which we're calling the advanced elevator script. And you'll see everything in the top of the script is exactly the same. And everything as far as the state entry also the same in terms of setting all the initial variables. The touch event is the same as well. That triggers the movement of the elevator, and depending on which floor we're on, sets the target to the other floor. And the initial part of the timer event is also very similar. We've narrowed the distance to determine when we're going to stop the elevator from a quarter meter to 0.15 meters, and everything else is the same. Once we get there, we're ultimately going to set that position and stop it. Otherwise, we're again going to continue the movement, and we're going to adjust the speed now based again on the distance. But in this case, we're going to factor that based on how close or far we are away from the target. So if we are closer to the starting point, we're going to move a little slower, and we're closer to the end point, we're going to move a little slower. But when we're in the middle, we'll actually move a little faster. So the speed in this case starts off based on the distance, which would be about 15 times 1.9. And so we're going to basically be moving a little slower at that point because it would take us about 30 seconds for us almost to reach the target in that case instead of just 15. So we'll be going slower. When we get towards the middle here in this factor, we'll be moving a little bit faster at a factor of 1.7. And otherwise, if we're not within that range, our speed will be 1.5. So as we're closer and further away from the target, we'll be moving slower. But once we're in the middle range between the start and ending position, we'll be moving at a factor of 1.5. And it's a very slight variation you'll see when the script actually operates. But in the middle, it'll move slightly faster, and then it'll slow down more as it gets towards the endpoints. And then we'll look at this last script, which we're calling the superior lift script. And again, you'll see the top part of this script is also very similar. Everything's the same as the last ones. But now what we've done is added a function called run lift at the top, which basically performs the movement function of the script. And we'll use that a little bit later. Everything in the state entry, again, is very similar and the same, except we've set a sit target event. You'll also notice that we turned the buoyancy off in this script and the one prior. Everything else is the same, but in this case, we've set a sit target. What this will do is allow you to sit on the elevator to trigger its motion instead of you having to touch it. And in this way, rather than appearing as though you're walking when the elevator moves, you're just sitting on the elevator itself. So we've added that functionality in this script. And so that's what the sit target provides. And once you actually sit now on the elevator, you'll see it triggers a runtime request, and then it runs the actual lift function that we showed above. And the timer event for this particular one sets the speed based on the distance, and this is uniform. As you'll see, it runs still relatively smooth, and because you're standing on the elevator, it looks smooth regardless of fluctuations in speed that are not present as you get closer to or from the takeoff point and the target you're trying to reach. It looks just smooth throughout the whole travel distance, but you're standing now on the elevator, and that's what's triggering this event. Once you stand, it triggers that, and it starts to move up and down based on standing. And once you get up, you have to stand again then to trigger it to go in the other direction. And so in this case, now you don't see your avatar appearing to walk as they're standing on the lift. In this case, they're just standing. In this case, we've used just a simple standing animation to demonstrate that. And so that's the basic function, and that's how an elevator works. And, there's some variations you can obviously imply based on some of the other things I've taught you in some of the other scripts. You can use buttons to function the up and down as well. You could build an entire elevator car to do the same thing that this one does, to make it much more decorative. And of course, you can add multiple floors and use lists and some of the other things I've taught you in some of the other videos. If you have any questions or comments, please leave them down below. I hope you liked the video. If you did, make sure you like and subscribe to the channel. And we have a few more things coming out in the future. Thanks again for watching, and you have a great day out there in Second Life.